Hello, my name is Ardi and we are going to solve problem 4.51 from Sadiku book. So the question is, given the circuit in the figure, obtain the Norton equivalent as viewed from terminal VAB and VCD. Okay. I think I will find the Thevenin first because it is easier than finding Norton equivalent. So in Thevenin equivalent, we need to find out the open circuit voltage between AB and also CD. So we can just find out VA, VB, VC, and VD. Right? Okay, maybe let's start by choosing this node here as our ground, which the voltage here is 0, which means that VD here will equal to 0. So our task is just find out the VA, VB, and VC. Okay. So now let's just write this, finding Thevenin voltage. So our target is find the VA, VB, and VC. Maybe let's just assume the direction of the current. This is going to the right, this is going down, this is going up, and this is going down. Okay, now maybe let's find out the KCL at node A. KCL at node A. Oh, that is not capital A, but small a. And KCL said that the sum of the currents that goes in is equal to the sum of the currents that goes out. Okay, now let's see this. The only current that goes in is from this one, which is 12 minus VA divided by the resistance between them, which is 6. And the other current is going out. This current here will be VA divided by 3. I'll have VA divided by 3. And then this one here, that is plus VA minus VB divided by 4. Okay, I think we can multiply both sides by 12. So I will have 24 minus 2 VA, and that will equal to 4 VA plus this will be 3 VA minus 3 VB. Okay, let's move this minus 2 VA to the right hand side. So I will get 9 VA, right? 9 VA minus 3 VB. And that will equal to 24. Okay. We can save this as equation number 1. Now let's do another KCL. KCL at node P. There are 2 currents that goes in here and 1 current that goes out. Okay. Now this current here is going in, so we'll have VA minus VB. And then divided by 4. And then plus this current here, that will be 6 ampere. And this current here that goes out, that will be VB divided by 2. Okay, multiply both sides by 4. I will get VA minus VB plus 24 is equal to 2 VB. Okay. Now what can we do from here? Let's move this minus VB to the right hand side, so we'll get 3 VB and minus VA, right? So I'll have minus VA plus 3 VB. That will equal 24. This is equation number 2. So we have this equation and this equation. We can just use elimination here. So 9 VA minus 3 VB is equal to 24. And this one will be minus VA plus 3 VB is equal to 24. We can just add them up. So I will have plus, I'll have 8 VA, and this VB will cancel each other, and that will be 48. And that means that I will have VA is equal to 48 divided by 8, which is 6 volt. And from here, we can calculate VB. So I'll have minus 6 plus 3 VB is equal to 24, or 3 VB is 30. And that means that VB will be 10 volt. Okay, we have VB will be 10 volt. And because node B and node C is the same, so I will have VC is also equal to VB. So this is VA, VB, and VC, and VD we already get it from this one. So we can get the Thevenin voltage. So Thevenin voltage for the node AB, I mean the terminal AB, that will be VAB. VAB, which is VA minus VB. And that will be 6 minus 10, which is minus 4 volt. And now the Thevenin voltage for CD, which is equal to VCD. That will be VC minus VD. VC is 10 and VD is 0, which is 10. Okay, now this is the Thevenin voltage. So we need to find out the Thevenin resistance. Okay, let's turn off the sources here. So I will have this 120 volt replaced by short circuit, and this 6 ampere replaced by open circuit. Okay, so now let's redraw the circuit. This is short circuit, and this is 6 ohm. And then this one here is 3 ohm. And then this one here is 4 ohm, if I remember correctly. Yeah, and then this will replace by open circuit, so we only have this 2 ohm here. So I will have 2. So now this is terminal A. This is terminal B, this is terminal C, and this is terminal D. Okay, now let's look from the terminal AB and determine the Thevenin resistance from the AB terminal. RTH from AB, that will be this resistance here for parallel with this resistance here is parallel to each other, which is 6 parallel 3. But then 6 parallel 3 is in series with this 2 ohm. So plus 2. Okay, so I will have 4 parallel with 6 parallel with 3 is 18 divided by 9, right? Which is, that will be 2. So 4 parallel with 2 plus 2, or 4 parallel with 4. 4 parallel with 4 is 16 divided by 8, which is 2 ohm. Okay, so this is the Thevenin resistance for AB. And now we need to find out the Thevenin resistance from CD. Okay, if we find CD, so the Thevenin resistance from CD, that will be this 2 ohm here. 2 ohm is in parallel with 4 plus 3 and 6 in parallel. 3 and 6 in parallel. So I will have 2 parallel with 4 plus 3 parallel with 6 is 2, right? We already calculate that here, which is 18 divided by 9. Or here we have 2 parallel with 6. Or this is 12 divided by 8, right? And that will be, we can divide this by 4, so I'll have 3 over 2, which is 1.5. So we got the Thevenin voltage and Thevenin resistance. So we can get the Norton current of AB. That will be VTH AB divided by RTH AB. And what that would be, that will be minus 4. Minus 4 divided by 2. That will be minus 2 ampere. So this is I Norton of AB. And we also can get the I Norton for CD, right? So that will be Thevenin voltage CD divided by the resistance of Thevenin from CD. VTH will be 10 and this one will be 1.5. And yeah, that will be 20 over 3, right? So I will have 6.33. 6.67, sorry. 6.67 ampere. So the Thevenin equivalent circuit will be this one here, because the negative sign we have the current going down, so I'll have 2 ampere, and the resistance will be 2 ohm. It's not in series, it's in parallel. That will be 2 ohm. And this is terminal AB. And for this one, I will have the current source will going up because it is positive. So it has 6.67 ampere. And I will have the resistance here will be 1.5. So this is the terminal C and terminal D. Hopefully I did not make any mistakes. Let's see. 2 ohm and 7 ampere. 1.5. This is 120. Oh. Okay. Yeah, I made a mistake. So this should be 12. But this is 120. But That's okay. So I will just change the problem. So my answer is for this one is 12 volt. But basically you can just calculate it like this, and see you in the next video. Bye bye.